Awesome. Thank you all for taking this time at 2 p.m. on a Friday. Um, the subject of the talk today is like pretty broad, but then I realized that pretty much every single person that's like talking about LLMs these days is using this in the context of computer vision or NLP. So then I was like, okay, so maybe we take this down the forecasting system path and see the points in which you can basically disrupt these forecasting systems, right? I'm not going to introduce myself. The reason for that is coming up in just a bit. Again, it's got to do with like Friday 2 p.m. effect. Um, and that's my LinkedIn, the QR code for that. I also write, occasionally on Medium. Feel free to connect with me. I look forward to, knowing you all. But let's get started, right? So today, from an agenda perspective, we're going to start off with an introduction. I have my AI avatar that's going to do my intro. Then we get into the high-level overview. So we're going to start really broad and then get super specific down to forecasting and down to forecasting systems. We're going to take a look at the status quo, and then we're going to identify the points at which we can disrupt the status quo and why so with transformers. Then I also have a few demonstrations. If time permits, I'm going to do 2 demonstrations. Share with you the code base so you can run this on your own. And then we'll finish up with some concluding thoughts, right? And some Q&A along the way. I'll stop to take questions. For whatever reason, I don't think I'll be able to see what's popping up on the screen at this point. So I'll stop from time to time to take questions. That being said, let's start off with who am I? Hi, I'm Sathish Gangichetty, and I'm currently a senior solutions architect at Databricks. I have a deep passion for human-centered AI and consider myself a lifelong student. In my day job, I spend a lot of time talking to machine learning customers in the US from retail and CPG industries. I help them think through problems and implement novel AI solutions. I'm also a dad of 2 beautiful children, and they're central to everything that I do. I look forward to spending the next hour together as we explore this interesting topic. Perfect. So the reason why I did this is because this video is only partially me. It's like one image of mine, and then the soundtrack is from me, right? But it serves a larger utility, in generative AI specifically, right? It's grounded in truth, but now you're able to generate something that can, potentially live past you as well, right? Why is this important? What's got to do with forecasting? We'll come back to this, the full circle later on as we double click on this. But with that being said, let's take a look at the high level industry use cases in forecasting. This is a very wordy slide, especially after the pitch roast. I don't intend to go into every single aspect of it, but I want to leave you with a mental model of thinking about all these generative AI use cases. Typically, it follows the 3 Ps, right? Personalization, planning, and productivity. Anything that you hear from anybody is going to fall into those 3 buckets or some intersection of these 3 buckets. I don't want to get into specific use cases, but I'll also simplify this even further, right? Everybody here has potentially heard about attention is all you need from the transformer paper. But guess what? Personalization apps, they're trying to grab your attention. Planning apps, like forecasting and things like this, they're trying to improve your attention to detail by automating away things that machines can handle really well. And then you have the productivity apps that are eliminating the attention overhead. So I guess when in doubt, fall back to the 3 Ps, and it should be okay. So with that, let's talk about the second P there, which is the planning system, and forecasting systems are a part of it. And let's examine how we can use transformers to disrupt like the status quo in this space. Again, part of this talk is to give you a high-level understanding of where the field's going and also what we see companies typically do. I'm not going to take up databricks point of view specifically because I have like this big ideas in here, and so you can choose to pursue this in your own projects or even in your own startups. Okay, so that being said, what is so special about forecasting? Why should people care about it? Number one, it is already a nail that's popping. Unlike many things in generative AI, you don't need to walk around with a hammer trying to find what the nail is, right? This is super, super valuable for most companies that have anything to sell. Think about from a mom and pop store all the way up to a big box retailer, right? Like Walmart, for example. But central to planning is all the processes that are central to planning is because of time, right? And there's a stat that McKinsey threw out like almost maybe 2-3 years ago. It's talking about if you improve your forecasting accuracy by 10 to 20%, you can actually get your top line to grow by 3%. Imagine what that is at $1 billion scale, $30 million out the gate in value, right? So you're not trying to prove value. And yet, it is also a very difficult problem to solve. Why is that? Like if you think about what happened this week in Lahaina in Hawaii, every single forecasting model that every retailer, comms company, or CPG company put out, that's going sideways because there's going to be this hand of God effect, right? And that's happens a lot in anything that is orchestrated by time, quote unquote. So by that's like forecasting. But how do these manifest in day to day? Like as far as our group here is concerned, if you're doing machine learning, data science, AI, something to do with forecasting, there are business priorities that are calibrated as really important business priorities that you need to be on top of. And then there's like stuff that you need to keep in your like periphery so that you can keep track of that. So that's how I calibrated this. Right now, the big thing that most companies care about is how do I achieve scale with all my use cases, specifically around forecasting, considering that if I get that right, I'm able to increase my margin, right? You have open source first distribution engines here. Work with distribution engines like Spark and Ray that already do this really well. But today we'll be specifically honing in on the two things that you see on the right side, which is transformers and the transforming aspect of it. We don't necessarily get into the transforming aspect, but transformers specifically around Patch GSD, right? But before we get there, we need to understand what is happening in most companies today from a very, very simplified lens. This is simplified specifically for the reason that you don't want to get muddled in the little nitty-gritty, but you can look at any system, and this is obviously not just forecasting, but essentially any use case, right? And can divide that across these three things. You have the compute layer, the ops layer, which is where you get your VMs from, the infra, the engine, which is the where you let your code rip through, and then you have your process layer and the serving layer. The process layer is like very specific to the use case, right? And this is, in this case, in forecasting, typically you end up having some product portfolio that you're trying to push to the user. And these products may already exist or may not exist. And you are most definitely going to have two separate forecasting processes, one for forecast generation for existing products, another one for new product forecasting. Once all of this is done, you figure out what your best model is, you write it off to some MLOps tooling that you have, and then write off the results to your database tables. Once the results land there, that's when you think about like, how do I surface this to my users? Either as apps, APIs, or dashboards, right? This is the thing that's happening right now with most companies, large companies. But income transformers, which allow us to meaningfully disrupt the status quo in the process layer and the serving layer, specifically around the forecast generation process, the new product forecasting, and how you enable your consumers to interact with forecasts. So the next thing we're going to do is we're going to go through each one of these three things and see how this is made possible. So let's go through this and figure out, models for existing products. I don't know what the profile of the audience here is. Some people may have done forecasting, some people may not have done forecasting. But a general trend that we see here is people constantly try to balance deep learning models with local econometric models like ARIMA, ESMs versus NBs and hits, right? This has been an ongoing conversation. But there's some history with transformers, especially with transformers being applied in time series forecasting. What that is last year there was a paper that was published which argued that transformers are just not good for time series because they were able to show that simple linear models outperform transformers in pretty much all the categories where they tested, often by a large margin. And they said like transformers are not really good for time series forecasting. So I guess what are we doing here then, right? So early this year, there's a paper that came out, was done by Princeton University and IBM Research. They call this Patch GSD, which is Patch Time Series Transformer. It offers a new way of using transformer models for time series forecasting. This is obviously going to be a high-level talk, but I'll give you two specific things that this paper calls out. And that's why we have this info here. I have this LinkedIn. You can go click through and go read the paper later on. But essentially, the notion is of channel independence. If you have a multivariate signal, like let's say you have sales with like weather and price and things like this, this model is going to treat each one of that as separate univariate series with a common transformer backbone. Turns out that if you did this, the transformer is able to actually share the embedding layer. And because of that, over a period of time with training, the results turn out to be significantly better, right? Also, they introduced another concept called patching, which is, think of patching from CNN days, right? Where you have patches of kernels moving through strides in the images. The same concept, if you take a certain sub patch of the entire time series and call that a patch, now you can actually use that as one single string of tokens into the embedding layer. And now that does three things for us, right? So now the attention map does not need to spend, it becomes so much more efficient, and the local semantic information of the transformer gets, locked in the sense that the transformer can actually learn from that. If you need to know more, you just go through and check out the paper. But with that being said, let's put this into, let's see if everything that they claim in this paper is actually real. Because if you read through the paper, they show some results, and these results are astounding in the sense that it beats all the other models. But I wanted to test this. I want you to test it. And if you think this is going to be great, you can actually use this in your own projects. And so with that, let's go test it, right? I have this training on the GPU, an A6000. And essentially, we're training three models, global models. Like I said, the Patch GSD, the N-hits, and the N-beats. These are supposedly the incumbents that need to be beaten in the space if you are going to claim that you're the best, like deep learning model in the space, Patch GSD, because that's where we start first, right? And it's training at this point. The training took about, 27 seconds for three models. And this data set is something that I picked up from Kaggle about Walmart's store department data. Has about 10 departments in this data set. And you can see, if you look at the symmetric map out the gate, you can see Patch GSD is pretty much beating everything else except for these two cases, right? So 80% of the time, this seems to win across N-hits and N-beats. Considering N-hits was touted to be the best model in deep learning for forecasting just last year, this is cool, right? So you can actually use these models should you want a deep learning solution for it. But let's test this against ARIMA models too, right? And if we did that, what we end up seeing is across those same department IDs, like I trained the ARIMA models, and you can see that the champion turns out to be 50% of the time, 1, 2, 3, 4, 5, Patch GSD at 50% of the time on ARIMA. So you don't have a silver bullet yet, with transformers. But what this says is you can actually use these transformers as a part of your arsenal when you do your forecasting processes. Again, look back to the value. The value is already proven. For a $1 billion company, on average, by getting the forecasting right, it increases your top line by 3% or 2%. That's like $20 million, $30 million of immediate value, right? I'm sure there's some company that might come in, and do specific startup around these things. But if you're doing this for your side projects, for your, projects at work, you could be doing this. The second part of it is in new product forecasts. Like we talked about, what if you had history? Can you be using transformers there? What if you don't have history? It makes it absolutely clear. Like you just had a startup present, like Cordova, and they're talking about how unstructured data is where like the wealth of the info is in, right? So the previous generation strategy, or the current generation strategy, is around this. What people typically tend to do is, hey, give me all the attributes of a particular product that you're going to launch, and I'm going to do clustering across all my entire product portfolio and figure out what this product is close to. It's highly problematic because most of these things that people have, identified as attributes are very sort of subjective based on who did the attribute, like who did the tagging at the time, right? And then you arrive at some individual point estimate to be made. But in fact, a step better than that is going to be something like an image search application, right? So I'm not going to show you in here. I don't know if you can see it clearly, but essentially you select a particular shoe and it comes back with like other shoes. Your regular vector search ideas, right? Nothing, super crazy about it. So I'm going to pause that right there. The idea that transformers bring to the table is you can actually now use multimodal models. It's not just your, how the product looks. Obviously, that is a big reason why people click on the, on the products. People read stuff on Instagram or what have you about the product description and come into your website. So it's the origination point of demand, and you can take advantage of this, right? And you can do this using these multimodal models and let every single product in your product stack and compute embeddings using that, using Spark or some other form of scalable compute. And then once you arrive at your nearest neighbors using semantic search, the whole process of figuring out what the new product forecast is fairly simple. What you do is you pick up the patterns from these individual time series, and then rescale and merge them between scale 0 and 1. Then you calculate the sales estimate for the next 12 months for the said, product, for every single product. You use those nearest neighbors estimates to arrive at an estimate for this brand new product and distribute that across the time series pattern we have. So this is a very automatable process. I don't think people are doing this today at all, and yet it's possible, right? That's the big idea, second idea in new product forecasting. The other thing in new product forecasting is transfer learning. Again, this is like a small detour. I just want to show you that transfer learning is coming to time series forecasting if you don't know. And it's also, I think Nixla put together a nice demo on Hugging Face. They show, hey, it's actually possible for you to train a pre-trained model. Let's say I use the NHITS, where it looks at a large corpora of historical time series data. And then once you have that, you can expose this, you can bring brand new data to it and have it forecast without doing anything, right? So zero-shot inference. So that's something for us to be aware of as we go through this, this process of introducing transformers to time series forecasts. So the last part is, okay, so you've disrupted how you do forecasts, you've changed how you do your new product forecasting. Next thing to do is, so when people consume your forecasts, either through APIs or through dashboards or through apps, today it's very confusing, right? Dashboards are hard to use. You got to go to a particular tab, click on something, and then click on something else for the results to change. People can easily get confused, and you don't remember those things, right? You want to make sure that the cognitive overload for the person using it is as small as possible. So then what we want to do is we want systems to adapt to us a lot more and be more human-centered. It's almost like I have this analogy where if you were living in a forest, back when dinosaurs were around, you're foraging the forest to try and find food. It's such a hard thing to have to do, but you still have a strategy to go find food. You want to reduce the burden, and it's akin to a child walking into a store and picking up what they want, right? The same story needs to happen to our systems. We should reduce the burden of entry for anybody in the space, and that idea stays true for even forecasting, right? So let's go see how this is actually possible today with time series models, right? I have a simple Gradio app. You should see that in your in the GitHub repo. So now we have a language user interface for time series forecasting. This is a simple demo, right? You can ask questions around hey, summarize all data for cereal in 2012. And I forget to mention, this is literally takes two hours for anybody to set this up, right? Just think of this like a single table Q&A. And the idea here is to do this, right? So I just use DuckDB for the backend tables, pandas to read back and forth, LangChain to orchestrate the entire thing, Gradio for the app, and then Plotly for surfacing the results, right? Now, this is super simple. Anybody can do this. You don't need to be a special data professional to actually, or somebody who understands the data to interact with this data, right? You can literally have a free form, question where you can say forecast for all categories in August 2012. So I would say 2012 because this data only has 2012 data. If I ask that question, immediately it's going to give me three things, right? If you're interested in high-level summary of what happened, here's what you get, right? So for your all across all the categories, Here's the forecast. And then the highest and the lowest, right? And you can be specific about a particular category or particular month, and that should still come back with something. So all of that to say that you can actually build out these LUIs very quickly with transformers. I'm using GPT-4 here, and if you're wondering what the backend is doing, is the tagging API that LangChain I think recently pushed out, which allows you to take define a Pydantic model and use that to arrive at. Let me show you VS Code. Arrive at something like this, where you have exactly what you're looking for, tagged by, in this case, GPT-4, and then it's just you trying to fit a particular SQL query against it. This does many things for us. One is it precludes your data being sent to any LLM, right? Secondly, when it maintains the privacy, it also ensures the determinism of the result. Meaning it's always going to be the same thing. You're never letting some LLM that rip through whatever SQL that it's able to generate and show that to the user, right? And that creates a sense of trust in this process where the results are constantly maintained or ensured, or essentially you're not dropping those, the user trust because it shows a particular technology. So there are ways for us to go through this and do it. So what I would recommend is if you're doing any kind of forecasting, or just for that matter, any kind of modeling the space, that in the space I mean in forecasting, definitely choose to add transformer models into your arsenal for time series forecasting, especially for high value items, right? So just like everything else in life, Pareto's law prevails, which is 20% of your products probably contribute to 80% of your revenue. For those products, at least, choose to use these. Take advantage of all the image and text assets. Automate, like somebody mentioned this in the last call too, automate everything where possible, and choose to use open source. And this is one thing that I take away from myself too. Wherever possible, bet on open source software. You see things like LangChain, Lambda Index, and things like this. The pace of innovation is so large that by investing in that, you actually 2x or 10x your chances of success down the lane, right? And then serve the results via LUIs when possible. LLMs kind of make this easy. Still needs to work. You need to still set up some amount of backend code, and it still works, right? So that's pretty much it. I went through that really quickly. Let me stop to take questions.